All right. In any triangle, if you are given the measure of angle A and sides A and B for each case, indicate the number of possible triangles with the given information and illustrate it with the diagram. Okay. So notice we're going to look at 6 different scenarios, and they each have different number of solutions, and that's what you want to look for. So when you're given an angle and you know A is better than C, so notice you're given side angle. Whenever you're given side angle, we have this issue where we have to check. Okay? So, because side angle, you know you use the sine law, and whenever that happens with SSA, you have to worry about ambiguous case, okay? That's the issue here. So always put your angle A here at the bottom. We don't know these side lengths, but B goes here, and we are told that angle A is greater than or equal to B, or side A is greater than or equal to B. So angle A is less than 90 degrees, so it could be 80 degrees, 7 degrees, 45 degrees, whatever. And you are told B is greater than, A is greater than or equal to B. So can you see if this is greater than or equal to B, there's only one possible triangle that can be formed. One possible triangle can be formed. So when the side opposite the given angle is greater than the other side, that must be B, right? Then there's only one possible triangle can be formed. Right? Because if I tried to draw A here, I couldn't form a triangle. They wouldn't join up the lines properly, right? If I try to draw A here, right, you couldn't, no matter how you try to draw A, you can only get one triangle when you draw it here, right? Otherwise, no other position will form a different triangle. Yes. You're confused by what?
What do you mean by if you draw? Oh, we can't connect all the sides. Oh.
You can't connect the sides properly. Yeah. Well, you're usually given A. You're given A as 70 degrees or 60 degrees or 40, whatever. You're usually given A. Okay? So, now, your given angle A is less than 90, so whatever that angle is, so let's just draw it. Always draw A here. Okay? You always draw A there. And you know B goes here. And they're saying A is less than B, but A equals B sine A. So, what does that tell you about this triangle? If you know sine A equals A over B, what is that telling you about this triangle? Like if A equals B sine A, what does that tell you about what kind of triangle this is? A right angle triangle. Right? If we know that A equals B, like A is less than B, it's the height of this triangle basically, then you know we have one, note the triangle, or note the altitude or height, note the altitude or height equals B sine A. Therefore, you have one possible triangle. In this case, it's a right angle triangle. One possible triangle. So, if one possible triangle can be formed, you only have one solution. Yes.
So that mean any triangle that has sine equaling B or A, or some combination of that is right angle?
Well, Not, well, B could equal A, but that doesn't make it a right angle. If if the side opposite the given angle equals the height, then you know it's a right angle, right?
If you have sine in there, then it doesn't tell you it's right, since the trig ratio is 90 for a right angle triangle.
Well, if you know the trig ratio is working in any triangle, you know it must be a right angle triangle, right? Okay, let's look at this one. This one is telling you the side opposite the given angle, so you have this A again, right? And it's less than 90 degrees, whatever that is. Again, it could be 59, 78, whatever. And they're telling you, here's my height, okay? Because the height is equal to B sine A. Agreed? Right? Because you know sine of A equals H over B, hypotenuse over the, no, sorry, opposite side over the hypotenuse, and H equals B sine A. Now, if they're telling you side A is less than B sine A, that's telling you we've got this side A here that isn't going to reach the base. Can you see that? If A is less than the height of the triangle, we've got this side A which is not going to equal the base. It's not going to reach the base. So 0 triangles are possible. Right? If the given side opposite the given angle is less than the height of the triangle, we're not even going to get a triangle. Yes.
How do you know that it's less?
You'll be able to calculate it, because in any question they're going to give you angle A equals 48 degrees, little a equals 5 maybe, and B equals 10 or whatever. They're going to give you 3 pieces of information. They're going to give you side, side, angle. Whenever they give you side, side, angle, there's this issue where we have to determine whether there's 0 solutions, 1 solution, or 2 solutions. Okay, that's just an example. Yes.
Do you kind of like go through like what each piece of information there means? Because I just like don't really get it.
We will eventually, but if you want me to do it right now, I don't mind doing that at all. Just let me get a piece of paper. We will do specific examples which will make this clear. I'm kind of giving you an outline of each scenario. So we will do that. If you can, maybe we'll just wait till that. Okay. Angle A is less than 90. A is less than B, but A is greater than the height. All right. So this is going to be, if this is angle A less than 90, okay. Now they're telling you, here's our height, here's our H. They're telling you A, here's our B. They're telling you A is greater than the height, so it could be there. But because it's less than B, it could also end up there. So here you have 2 possible triangles. If our height is here, right, and A is between the height and the other given side, there's 2 possible triangles. 2 possible triangles. And that means there's 2 possible solutions. So I'm giving you an overview of all the possible cases, and we'll actually crunch out numbers, and I'll show you why this is so. Yes.
Does A have like when A is less than B, does it have to be inside of the like the height like true, or can it be
Yeah, because if I try to draw A, I'm not going to reach the base. Like if A is less than B, then it's going to end up there, right? So this is where it will hit the base here. Okay? Okay, now we're dealing when angle A is greater than 90. So it looks like this. And here's B. A is less than B. If A is less than B, then we run into this situation. There is no possible triangle. Right? When A is less than B, and A is an obtuse or greater than 90 degrees, there's no possible one. But if A is greater than 90, angle A is greater than 90 degrees, A is greater than B. Here's our A, and that's greater than B, then we're going to get one possible triangle. Those are the 6 scenarios, okay, that you need to be familiar with. And I've highlighted them over here, and we're going to do some number crunching so you get the idea. When angle A is less than 90 degrees, and A is less than the height, see, A is less than the height of the triangle.
Why is the height in sine A?
Because the height, if I draw in a right angle triangle here, sine of A equals the height, h over B, so h equals B sine A. The height of the triangle is B sine A. Yes? Oh, I thought that was a question. Right? So if A is less than the height, you're going to have 0 possible triangles. When A equals the height, right? When A equals the height, you're going to have 1 triangle. And it's going to be a 90-degree angle or a right angle triangle. This is a case of the right angle triangle. When A equals the height and it's less than B, which it would have to be, right? Now, when A is greater than B, it's easier, right? When A is greater than B, you know you only have 1 triangle. Now this is where it's tricky. When the side opposite the given angle is greater than the height, but it's less than B, then you have 2 possible triangles. When you have 2 possible triangles, you have 2 possible solutions. And then when A is greater than 90, if A is less than B, 0 triangles are possible. When A is greater than 90 and A is greater than B, you have 1 triangle is possible. So here, when it's 0, there's no solution. Your calculator won't be able to calculate. This is no solution here. 1 solution, 2 possible solutions, 1 solution for them. Let's just practice this a little bit. Angle P is greater than 90. Oh, is less than 90. Draw your angle P. And they tell you P is longer than Q. Q should always go there. And P is longer than Q. When you know P is longer than Q, you have 1 triangle possible. I'm just reinforcing these ideas. We're not into number crunching yet. This one here, if there's 1 triangle, there's 1 solution. Now, when P is less than 90, this is part B. This is getting a little bit crammed. So you have your P here. Now they're telling you the height is less than P is less than Q. Q goes here, P goes, so if our height is here, this is our height, height is less than P is less than Q. So P is greater than the height. You're going to have 2 possible triangles, 1 here or 1 here. PP. So we have 2 possible triangles. Let's do C. P is greater than 90, that's going to look like this. Q is here. P is less than Q, 0 triangles are possible. When P is greater than 90, and here's P is greater than Q, we have one triangle. That's D. Is it sort of making sense? A little bit? Yes.
So wait, angle P can equal 90, right? For
If you know if it equals 90, you're ending up with a 90 degree. You're ending up with a right angle triangle.
the same things apply, right? Even if it's 90 angle.
Yeah. I guess it usually doesn't, we don't usually run into that case, but yeah, it can happen. Let's go. Solve the following triangle. Let's do some number crunching and hopefully it will make more sense. Solve this triangle. Always put your given angle there, so if you always follow the same pattern for every question, it will make it easier. So angle A equals 58 degrees. You know B equals 10, so B must be here, little b must be there, side B is opposite angle B. A is 20. So you know angle A is less than 90 degrees, and you also know A is greater than B. So how many triangles are possible? One possible triangle. That means there is one solution. So let's do it. Side angle. So we can go 10 over sine B. Why don't we put we're going to have to solve the triangle, we'll call this C. So we're going to have to find little c, angle B, angle C. So let's do it. 10 over sine of B, right? I'll just put it in here, equals 20 over sine of 58 degrees, equals C over sine of C. What would be the first thing we should find? What's the first thing we can find? Sine of B. So let's do that. 10 sine 58 degrees equals 20 sine B. Sine B equals 10 sine 58 all over 20. Angle B is equal to inverse sine 10 sine 58 over 20, and angle B is approximately equal to, if you plug that in your calculator, you'll get 25.0889 degrees. Okay, now that we know B, we can find C. Angle C equals 180 minus 58 minus 25.0889 degrees, and that's approximately equal to 96.911 degree. Now we can find C. 20 over sine of 58 degrees equals little c over sine of 96.9111 degree. C is approximately equal to 23.4. So, let's do our summary. When they say solve the triangle, I just want you to do a summary of what you had to calculate. And we're going to do everything to one decimal place. So angle B is approximately 25.1 degree. Angle C is approximately 96.9 degrees. And side C is approximately 23.4. That's all I want you to do, is just write a summary of the things you had to calculate. Can I explain anything better? Now it says solve the triangle. Okay, so again, always write your angle A here, and then that way you won't, if you always fall in the same pattern, it's least likely to cause you any issues, okay? So here we're given angle A is 71 degrees, B equals 17. Before I draw this, I want to compare A to the height. I didn't have to worry about that here because I already knew A was bigger than B, so I know there's one triangle. This one I'm not too sure about. A is less than B, but is it less than the height? If it's less than the height, it's going to be zero solution. So sine 71 equals h over 17. H equals 17 sine 71 degrees. H is approximately 16.1. Oh, we know that the height is less than, right? No. Yeah, A12 is less than 16.1. So 12 is looking like this. Do we have a triangle? No. No triangle possible. Therefore, no solution. It's not going to reach our base, right? May I explain anything better? Can I elaborate on anything here? Okay. Uh-oh, I guess you know the next one's going to be the ambiguous case, right? Let's compare it to the height. Let's calculate our height. We know B is 230. So, and our A, we're not sure yet what's happening, okay? So let's just calculate it and then we'll decide. So we're going to go sine, H equals 230 sine of 35 degrees, and that is approximately H is approximately 132. Let me calculate it. 230 sine of 50, 230 sine of 35 is approximately 131.9. Okay, so A is greater than the height. A is between, so A, here's our height. Our height is less than A, is less than B. Agreed? So therefore, whenever A is between the height and the other given side, we know we have two possible triangles. We have this and we have this. So we will call this B, angle B1. We'll call this B2 because we're going to have two solutions. We will have two solutions now. Because this A can either go here, which is A is 133, or it can go here, 133. Two solutions. So I'll just write out the numbers. 132 is less than 133, that's about 132, is less than 230. Therefore, two triangles, two solutions. So let's do it. We'll do solution 1 here and solution 2 here. solution 1. Sine B1 over 230 is equal to sine of 3/5 over 133. Notice I'm working with the big triangle here. This one here is equal to sine of C1 over little c1. So this is going to be C1, right, the big side, and this is going to be C2, the little guy here. So angle B1 is equal to inverse sine of 230 sine 35 over 133, and that is approximately 82.7021 degree. Now, right away, angle B2 is equal to 180 minus this. Right? Because this is a related acute angle. A related acute angle, the sine of a related acute angle and the sine of 180 minus the related acute angle are equal. Those trig ratios are equal. So you have this ambiguous case. If you were to calculate sine of 82.7021 and the sine of this, you would get the same answer. Right? It's ambiguous. We're dealing with this ambiguity. Here's 82.7021 and, right, 180 minus 82.7021. These two guys have the same trig ratio. That's why we have this ambiguity in our calculation. So you have to do two solutions. Yes?
Could you just point out where angle B2 is on the actual triangle?
Yeah. Why don't I draw? Here. Let me draw it so it's nice and clear. This is A, B1, C1. Fair enough? Then this one is B2, C, oh, that would be A, sorry, that would be C2. So B2 is here. Do you see it's larger than one? It's larger than this guy, right? This one's larger than 90, this one's less than 90. Yes?
So are the two triangles the one on the left and then the whole thing? Or like the one on the left and the one on the right?
Okay, the solution 1 is this triangle. Solution 1 is triangle ACB1, this big triangle. Solution 2 is triangle ACB2.
Okay. So the one on the right is not a triangle. Separately.
This one, no. Well, that's not of interest. This guy here is not of interest. The guys of interest are this guy and this guy. Okay? Okay. Angle C2 equals 180 minus 35, right? Using the angle sum theorem, minus 82.7021. And this is approximately equal to, what am I saying? That should be C1, right? That's my bad. We're in triangle solution 1, right? This is approximately equal to 62.2979. Now we can calculate this little guy, right? So we have sine of 35 over 133 equals sine of 62.2979. Let me make that clearer. 62 over C1. So C1 is approximately equal, well, here, let me write it like this. Is equal to 133 sine 62.2979 over 133. No, sine of 35, my bad. And that's approximately equal to 205.3. So our summary, angle B1 is approximately 82.7 degrees. Angle C1, I keep on wanting to write 2, is approximately 62.3 degrees. And little c1 is approximately 205.3. Can I explain anything better? We have to do solution 2. Angle C2 is equal to 180 minus 35 minus 97.2979, and that's approximately equal to 47.7021. So C2 over sine of 47.7021 equals 133 over sine of 35. C2 is approximately I assume you can do the number crunching. Make sure you're in degree mode. Our summary, angle B2 is about 97.3 degrees. Angle C2 is about 47.7 degrees, and little c2, the side c2 is 171.5. Please practice that because you know it's on the test, right? Ambiguous case with two solutions is always on the test. And I feel badly about that homework question. I will do it and post the solution up there so you can have it. And I guess we'll call it a day.